So good afternoon everybody, myself Acharya Vishvendra. Today I shall be discussing about pressure. Let's discuss the sheet of pressure. So here is the worksheet. It's a level 1 worksheet, the very basic level. So the first question is, what is dimension of pressure? It is m1 L minus 1 T minus 2. Next question is SI unit of pressure. It is Pascal or Newton per meter square. Next is CGS unit of pressure. It is Rad per centimeter square. Next is units of pressure. So there are several units like Pascal, bar, ATM, torr, mmHg, cmHg. Now there is another question. There is a liquid of density D and there are 3 points given A, B and C. We need to find pressure at A. So A is open to atmosphere. So here pressure is P0. Pressure at B. So we know that P is equal to P0 plus dgh. Here it is h by 2. The pressure will be dgh by 2. Next we need to find pressure at C. So this is P0 plus dgh. Next is there is a graph of pressure versus height. So pressure is proportional to h. So height graph will be a straight line. Suppose this angle is theta. So from calculations we can say that tan theta is equal to d into g. In the next question there are 3 different liquids for which graphs are drawn. As you can see from the graphs that theta 3 is greater than theta 2 greater than theta 1. That implies tan theta t3 greater than tan theta 2 greater than tan theta 1, which implies d3 greater than d2 greater than d1. Now there is a composite liquid problem. Suppose there are 2 liquids which have densities d1 and d2 and heights h1 h2 as shown in the figure. In the very first question we need to find pressure at A, so it is equal to P0. In the next question pressure at B, so this is P0 plus d1 gh1 as the density of this liquid is d1 and this height is h1, so correspondingly we get this pressure. Again we need to find pressure at C, so pressure at C is gonna be pressure at B plus d2 gh2. So this is going to be the total pressure. Next is another question. There is a liquid of density T. There are 2 points A and B. So the pressures are related by pressure at the lower side is equal to PA plus dg into H. In the next question, this system accelerates vertically upward. So you just replace G by G plus A. So pressure will increase because ultimately if the system is accelerating upward, so there has to be a net upward force on the liquid itself. That means pressure at B will increase. So you just replace G by G plus A. In the next question, if acceleration is downward, then you replace G by G minus A. Pressure will be this. In the next question, if there is A is equal to G, which corresponds to free fall, then there will be no pressure difference, as in this formula if you put A is equal to G, this expression will be 0. So PB is equal to PA. Next there is a question that in which you just put a fluid of density D into a tube of length L and rotate it with certain angular velocity. So obviously pressure difference will be created because for rotation centripetal force is required. So that centripetal force will be given by the pressure difference. It involves integration, and after the calculations we have PB is equal to PA plus d omega square L square by 2. This is the relation. Next one, now if we have we are rotating this about the perpendicular bisector, then we have PC and PB as equal to rho A plus d omega square. L over here will be L by 2 whole square. So in this way you can calculate the pressure. So this is basically the level 1 worksheet, which just ensures that you actually solve problem on the basis for what you are studying. Normally what happens is when a student starts studying, he is not clear about why he is studying. He thinks sometimes, he learn, he remember, he memorize, he analyze. There are so many processes going on inside the head. But if these processes are not optimized, then there is no use of such processes, because everything is about the result. If there is no result or no output, there is no need, no rewards for the practical work you are doing. So here we can refer to this, and you can refer to the next videos for the next cases. Thank you. Have a nice day.